Hi everyone, good afternoon, and I'm Farnaz, PhD candidate in Adelaide University, and I'm working on a computational approach to the parametric design of kinetic Islamic geometric patterns with my great supervisors, Jane Burry, David Kroll, and Peter Charles. During my master program, actually my master program was in digital technology in architecture, and my interest in computational design and kinetic structures began during that education. And after that, I had the opportunity to be a member in a group named Altec with my supervisor Asafi, and during this team we worked on different kinetic structures in real scale and small scales by holding various workshops. And after that, I continued this topic in my paper, in my case, and in patent. And when I decided to combine these kind of kinetic structures with a specific forms and patterns, I started my PhD, and I'm here now. Okay, have you ever noticed some specific forms of patterns catch your eyes instantly and hold your attention? It's exactly the magic behind Islamic geometric patterns. They captivate their people's eyes and guide the mind toward inherent movement of these geometric patterns, and it's completely based on the inherent movement that all rooted in ambiguity and multiple layers of interpretations. And when you observe these kind of patterns, the mind doesn't see just one fixed specific pattern or specific form, but several subtle forms can be observed, and which keeps the mind engaged, and your mind try to find several meaning and interaction. These geometric patterns and designs are not unique for a specific period or specific country or culture. There are lots of examples and buildings that contain these kind of patterns all around the world in different time. During the early history of the Islam, designers reshaped some patterns from the previous civilization, from Persian and Roman patterns, and they developed these kind of patterns. And this kind of development and advancement to provide some sophisticated patterns was because of the advancement in science and mathematics. The patterns, once drawn by the artist's hand, and with some simple tools, and everything starts with some simple circles, and by dividing these circles into different parts, most patterns are divided into 4, 5, or 6 division and equal parts, and each parts of these divisions create different kind of patterns, and it become easy, and it's easily determined pattern based on the 4-fold or 5-fold or 6-fold based on the symmetry. Now it comes into the digital world, and we imagine through soft ways and computational designs where traditional forms meet some modern technology and open up new doors and new possibility for designing and innovation. There's another secret behind these kind of patterns named underlying generative tessellations. It's invisible, but one of the main important part of these kind of patterns, it's like a grid that helps determine the scale of patterns while you want to design a new form or keep the pattern's accuracy and make it feasible to innovate and design some incredible new patterns. It's This kind of tessellations can be easily found in Eschler's work as art designs. An example of underlying generative tessellations that highlighted in gray color, and the main lines of Islamic geometric patterns that represented in gray lines. And the main question is that how can these timeless geometric patterns address today's needs and in contemporary architecture, and can burst life into the architectural environment. Even the importance of transformability and responsibility in contemporary architecture, and because of some important role of historical geometric patterns in architectural design, maybe introducing these kind of patterns into computational methods present a practical and user-friendly approach to achieve some parametric and kinetic Islamic geometric patterns. Kinetic architecture is a common and maybe familiar concept to all of us, particularly in the facades or large scale structures, where motion and transformability are increasingly integrated into designing process. And these kind of kinetic structures, because recognized for their flexibility and interactivity, can transform the spaces into dynamic and responsive environment and play significant role in adapting and adjusting their environmental issue or surrounding built environment to different conditions. That is where my research comes in. The computational design tools allow for the developing of kinetic Islamic geometric patterns that can move, transform, and respond dynamically in different situations by producing new patterns during the transforming. For designing these kind of kinetic forms from these static and decorative patterns, it's the first step that breaking down these kind of patterns into its smallest units named fundamental domain. And again, by breaking down the fundamental domains to multiple line segments, it's possible to change just the angle of one line, and at the end we can find that the whole form of the patterns will be changed because of one changing of the angle. While these kind of transformability achieved, points travel on along a line from the center of the polygons to middle of the sides. And when static patterns are transformed into the kinetic forms, they actually define some key points that can be defined as a joint in physical prototypes in real architecture. And also my research demonstrated a novel approach by introducing and classifying some elements in these kind of patterns, the elements that is based on the lines of the geometric patterns, and based on these kind of based on these kind of linear elements and some intersection points as a joint, it's obvious that some specific structures, for example, Caesaric structures, demonstrate a high level of similarity and capability to follow these kind of kinetic structures, and their ability for offering some rotating forms of points in their inherent provide good options for us to make this kind of fixed configurations kinetic. This proposed kinetic mechanism based on Caesar structure is also possible to apply to a wide and extended form of the geometric patterns to cover a large space. My research and my study provide an algorithmic approach and computational method to design parametric modeling using Rhino and Grasshopper as a visual programming tool to configuring this kind of pattern in both static and both kinetic forms that are not non-modular and that are not symmetrical form. This kind of developed visual script is fully modular and with some clear structured frameworks and labeled components and defined some inputs and outputs and make it easy for non-authors or people to use or to edit or adopt this kind of script more easily and use in their design. These finding and this mechanism were validated through physical prototypes, which confirm that this kind of designing can be practical and effective to generate some patterns. And in this step that I'm working on small scale prototypes to prove that it's possible to use this mechanism for making these patterns kinetic, laser cutting can be an effective fabrication method that enable to produce some physical prototypes by using various materials. In my research, I mainly focused on this step. I mainly focused to confirm that these kind of patterns can be practical in kinetic architecture, and I'm applying this kind of architecture, this kind of kinetic structures in buildings, and it's possible to use these ones in urban design, urban spaces, to improve some flexibility and transformability in responsive facades or shading devices or maybe retractable roofs. Also, it's a great opportunity to generate new and various patterns and create interactive cultural and artistic experience. It has also it's also possible to integrate these advanced technologies in this kind of patterns, for example, using some sensors or some motors to make it kinetic based on some environmental issue, and so it contributes to sustainability since it can regulate some factors, for example, light or heat. So far, my analysis mainly focused on a specific group of patterns and specific buildings. The next step is to extend these algorithms for various forms of patterns and generate new forms of kinetic patterns, and also it should be tested in real scale to prove that it's possible and validate its possibility in architectural applications, and incorporating some sensors from and Arduino-based systems to achieve some real scale prototype. Thank you so much for your attention. Questions?
I really enjoyed that. Thank you very much. I think there are a few challenges to overcome as you make the leap from single line patterns into something that's going to be part of the building or an urban environment. And I think part of that is setting the brief for what you want. Like, what are you hoping to achieve with these patterns and with this, with it being kinetic? Like, what is that unlocking? So, you know, if it's maybe in an urban environment and you're talking about a shading device which you want to basically fold away and become very small, then what you've already done is perfect. But if you're looking at a facade system, for instance, generally the whole system is not going to be able to shrink. They will shrink in modules. They the aperture will open and close, but broadly the whole system will remain the same size because it has to. Whereas, you know, the examples that you had in Rhino showed the whole system shrinking. So I think they're going to have very different ways in which they function in the way that they move. And I think you need to almost set yourself that brief, what's the applications you're aiming for. And then another consideration is actually the third dimension that, you know, the example of the Al Bahar Tower, it's a curved facade. So how would this kind of system work in that instance? So I think, you know, there's a lot of rigor put in how the pattern works in 2D on a screen. But when you make that leap into the real world, you just need to set out what your brief is, what you're hoping to achieve, and then what are the constraints that are going to have to be applied to that thinking.
About the changing the size while opening and closing, there are two approaches for making these kind of structures kinetic. The first one is having fixed perimeter and changing the lengths of the elements by some telescopic elements. And the second approach that I focus in this prototype is mainly keeping the length of the elements the same during opening and closing, but changing the perimeter during this kinetic and transformation. If it's for facades, the facade have some frames to keep this kind of frame, this kind of kinetic parts. It's a 2-layer facades, and this kind of small changing can be supported by the frame behind that geometric patterns. And it's also possible to use some telescopic elements that while opening and closing change the length and make it possible while it has some fixed point on the frame. And of course, it needs some less points as a fixed point, but it needs to control the length while opening and closing.
Yep.
Hi. As part of your research, have you considered kind of taking a step back, stepping away from the computer and engaging with the spiritual traditions that are behind these patterns? You know, perhaps like either the Sufi tradition or something non-Islamic, something with psychedelic breath work or substances or other kind of techniques that get into the altered states of consciousness that originally inspired these kind of patterns?
Actually, my analyzing of the geometric patterns at first started from the analyzing the geometry besides this kind of patterns, and this design is not maybe linear analysis. It has some interactive points. At first I start from the analyzing some simple patterns by geometry, and after that I tried to parameterize these kind of patterns. Again, I built some prototypes. And after that, again, I came back to some geometric analysis to find some points, again, some physical prototypes. And in this way, I look at these kind of patterns from different points, not just based on some computational design, since this kind of geometrical design or some scripts of grasshoppers need some logics, and these kind of logics should be achieved through the analyzing of the geometry or the roles of the lines, transitions.
Great work. I love this type of pattern. Couple of questions and one comment next. Firstly, I want to know how you want to bring this into non-planar geometry, like curvature. That's one thing I wanted. And the other thing is that when you're changing this type of elements within your facade, like how are you going to think of origami structure, something that folds away? Because like this line's gonna be, there would be something between them if you want to have a kinetic stuff must stretch, or you know, so there might be something that you want to think about origami there. And the main question that I have is, this has been done, like what do you think that the main contribution of your PhD would be toward this type of?
Okay, about the first question, designing some 3D forms of this kind of patterns is based on designing some 3D elements and 3D details of joints. Then it's possible to use in different forms of curves. And for some normal curves, it's possible maybe by defining 3 forms of elements. But for some free forms of curves, maybe I need to define different forms of elements and different forms of joints for making some kinetic in free form. About the using origami, since I worked on these patterns and I mainly focused on preserving the main principles that embedded in this kind of patterns, since I want to preserve the continuity rather than deviations during the design, I found scissor structures that can completely follow these kind of principles. Yeah, it's a good idea to focus on this kind of origamis, but I'm not sure that these kind of structures can help to again continue this kind of identity of these kind of patterns that I put in my first step for main role in designing or not. But it's a good idea for maybe for covering the space and following the, and about about my contributions. Actually, in my point, one of the main contributions is that I provide a visual tools for others to use this kind of components in Grasshopper that's easy by defining some inputs and outputs, not to rework about that one, and I'm reducing the process. Also, I encourage the architectures to bridge the gap between traditional architectures and our contemporary architecture, since these two are main part of the architecture, and this research can combine these ones and integrate these two main parts and provide some new method for designing. And the other part of my contribution is to provide some physical parts that is interactive in this space and useful for architecture in a practical way.
Great. Okay, I have a few questions, many, but probably I'll just ask for you and then we can have a chat. My first question is why Kinetic? What value it brings to your project? What is your project? What is the case study? Is it big? As Andy also highlighted, is it the shading? Is it about space saving? Is it about what? And that will definitely would be a driving factor in your design. Back to the Al-Bahar, it had a context. We cannot have another Al-Bahar elsewhere. It's responding to its context because of many dimensions. Its cultural dimension is one thing behind the design of the pattern, also the climatic factor. So if the Al-Bahar is your case study, probably you need to dive deeper into the reason behind. You showed the Al-Bahar as example, so definitely the audience is gonna ask the question why Al-Bahar out of many other kinetic has been shown on the screen. You refer back to the pattern from past. Probably it's another question. What can you learn from past that can be generalized? Or to what extent can you expand it further? For example, part of the driving force behind those beautiful patterns you showed was the limitation of fabrication. For example, they wanted to achieve complexity out of simple motif. So by designing 2 motifs, they could have achieved complexity, but without losing that complexity, I mean, to the simplicity, but simple in a way that is achievable and easy to construct. So that's the driving factor. What is the driving factor behind your design? That's probably something that you need to to have some value. Why kinetic? Why that pattern? What can you learn from past that can be carried further, rather than just the visual aspect of it?
Thank you. And about the Al-Bahar, I have the Al-Bahar as a kinetic architecture example, and it's not related to geometric patterns or anything. And my case study is based on some geometric patterns as in different places. For example, my first paper is based on the mosques in Isfahan, since it has many rich 10-point star patterns in architecture. And in the first step, there are as a case studies about the kinetic. Since our architecture in contemporary designing needs some adaptability and flexibility for answer and for adapting to different situations, to different needs of humans. So this kind of kinetic architecture is always valuable for designing, and combining this kind of structures, kinetic forms with some specific pattern can provide new forms, not some regular and repeated form of the patterns that are common in different kinetic examples that are known in the world of kinetic architecture.
Hi, I just want to share something with you, maybe it be interesting for you. For all of these patterns, sometimes because they go like hundreds, they will use like hundreds of years back. And in that case, you find a lot of spaces. They could just do flat roofs.
Mm-hmm.
So you go like doing domes and vaults. And what's really interesting was that at that time, like there's not much of a building technology, but they can like make these patterns conform to the free forms of these types of roofs.
Yeah.
So it can be interesting to find like maybe tiling approach that looks interesting and at the same time can be maybe like sustainable.
Mm-hmm.
That, you know, instead of just conforming to the normal, you know, like tiles that need to be going with like a free form thing, maybe doing a pattern like that can be an addition to architecture too. So just a thought. I thought I wanted to share it.
Thank you.
At this time.
There's 3 minutes.
Okay. I've been racking my brain as to how to use this. And it's been hard. But I think I might have an application. Have a look at composite metal panels.
Mm-hmm.
Specifically, there was research done where they had different alloys of metal laminated, and so that when the panel was heated, the metals would expand at different rates and curl to shape and shade a space. But it's very much down to passive environmental conditions so that it would do that. I feel like if you were to take two of your systems and have them work in a composite way as a dual graph, you may be able to control the curvature of a panel with only one linear actuator, which is one of the things that facade designers, especially ones that are trying to do kinetic facades, they're trying to reduce the amount of actuators. So if you can take that down to just a single movement that takes an element from curving to be straight, it might be enough to prevent enough sunlight getting into a space that you would normally have to make up for with air conditioning. That's where I think maybe this could have a really big impact, because it would also be something that's hidden architecturally within the panel, rather than something, you know, the various different pneumatic actuators that you see over those facades. And it would mean that the maintenance would be reduced down to fixing up that one linear actuator. So that's like, it might not be where your research is going,
But from an application perspective, that's where I think that the easiest path for this to move down is.
Thank you.
Thank you very much. So can we give a round of applause to Farnaz?